Hi, I'm Victor Agreda Jr., and this week on Coders, we're going to look at the amazing amount of stuff that came out of Google I/O yesterday, and we're going to take a quick look at an actual Arduino project. But first, from our sponsors. Thanks.
CommScope, thinking beyond today's technology to help you make the best decision for your network and your business. Telecom Careers, the #1 global telecom and wireless job board, telecomcareers.com.
Hi, this is Victor Agreda Jr., and thanks for joining me this week on Coders. We actually have a lot of stuff to cover because Google had their I/O conference yesterday, and so there was a whole lot of announcements coming out of Google. They have been working worldwide, of course, on a number of different projects that saw some fruition yesterday. Uh, so let's get started at some of the top level things, and then we'll drill down into some stuff that actually impacts developers and other folks in the networking and wireless and carrier areas. First of all, HBO Now is coming to Android. This started out as an Apple exclusive, and as I suspected, media companies are not really beholden to any particular platform, and HBO, of course, is no different. They're looking to monetize, and it only made sense to bring HBO Now to Android. So I think that was a pretty done deal. There are a couple other media things, but one thing that, of course, is huge is the announcement of the next mobile operating system, Android M. And I guess that means that they're getting away from the candy stuff. But M is going to include Android Pay. And this is important because it's really just Google Pay, except now it's going to be integrated into the OS. And now that Google is going to be, something else they announced was that they're going to be allowing biometric readers, authentication, fingertip sensors and whatnot to authenticate. So this actually brings them up to par with what Apple's been doing with Apple Pay. And I think what you're going to see is, again, the payments, the mobile payments are going to take off. Now you've got Apple and Google basically at an equal footing. Future devices are going to be able to utilize this, and you're going to see a lot more people paying at Starbucks with their phones. So we mentioned the biometric support. Some other things that they talked about were DOES is a low power mode. So it detects when your phone isn't being moved or isn't being used, and it puts in this sort of low power mode. But the big thing, wearables and Internet of Things. Google is obviously very interested in getting into your living room, on your wrist, in your car, pretty much everywhere where you're living your life, right? So, Internet of Things, this was some big stuff. Android based OS for Internet of Things devices called Brillo. And Brillo is their attempt to sort of bring things under one umbrella, and people can develop things using Brillo to deploy as an Internet of Things device in someone's home. They also introduced a protocol called Weave, and developers can use either one of these, or they can use this one, or they can use both if they want to. So we'll see how this rolls out over time. But the other thing that I thought was interesting is now we're starting to see a little bit of a fragmentation in the home automation, Internet of Things space, which we knew was going to happen because multiple manufacturers are going to be coming out with different platforms. The big one here is that Apple has HomeKit, and I expect that we'll see a lot more about HomeKit at WWDC, which is next week. So it's going to be interesting to see how Brillo and Weave versus HomeKit plays out. Will developers have to include two sets of code that say, well, if you're using Brillo or Weave, then you got to do this, and if you're using Apple, then you got to do this? It's going to be an interesting thing to see how that shakes out. Of course, what consumers want is just something that works, something that they can plug in and they can fire up their Android or iOS device, or maybe both, depending on the household, and utilize all of their smart home devices. So we're going to see how that implements over time. A big thing is speech recognition has improved dramatically. And I had to wonder how much of this is due to upgraded networks, upgraded hardware. But I think really what they were trying to focus on is that they went from 23% error rate in 2013 to an 8% error rate in 2015. That means machine learning. And that's obviously getting huge. And Google is very, very interested in machine learning. And to that end, they introduced a couple of other things that assist with that. You may not realize it as a consumer, but Google Now has been beefed up to the point to where it has pretty much surpassed Siri. Now, there were some things that Google now could do that Siri couldn't do before, but they have just gone even further. And now Google now is able to use contextual information that's going on your phone to give you answers. So one of the examples was if you're listening to a Macklemore song and you want to say, "What's his real name?" It will figure out that you're listening to this specific song and figure out that his is meaning Macklemore, and it will go and try to find his name without you saying, "What's the real name of Macklemore?" Other things is when you're seeing something on the screen, let's say you see a restaurant or whatnot, it will recognize what you're looking at and try to make recommendations based on that. So Google now has just gotten a lot better. Then we've got Google Photos. And I think for carriers and telecoms, this is a big thing because if you thought that your bandwidth was being used, get ready. People now will have infinite storage, unlimited storage with Google Photos. One of the biggest things was taking Google Photos out of Google Plus. You may remember we had Picasa, and then Google rolled out Google Plus, and Google Photos were a part of that. Well, now it's spun off. It's a completely new thing with iOS, Android support. Uh, but the big deal is that people are going to be using this as a way to back up their photographs. It's free. It supports up to 16 megapixel pictures, 1080p video. There really is no limit. And yeah, you get a terabyte with Flickr, but the interface is terrible. I think one of the coolest things for me as an interface guy was seeing a grid of photos, and he was able to just click and actually drag his finger down and select all of them. And I thought, I don't know why Apple doesn't do this since they invented click and drag, sort of. But at any rate, Google Photos is going to be really huge for consumers, and that's something to keep an eye on, especially if you can, use their API to write apps in it. Uh, the other thing is, and I think for telecom folks, this is a big deal because what you have right now is a proliferation of smartphones, and Google had some interesting stories about this, about how more people are coming online every day with smartphones. Of course, this is a given. But what they're seeing is that a lot of smartphones, but the infrastructure is still taking its time to work out, to build out in some markets. And so in those countries where you have perhaps a lag between the infrastructure and the connection, the devices that are connecting to that infrastructure, Google's working really hard to try to make that experience better. So some of the things that they're doing, it kind of reminds me of some of the stuff that Opera did in terms of compression and whatnot. They're really trying to speed up the Google homepage and search results if you have a spotty connection. Another thing that they're doing is taking a lot of things offline. And of course, some people had YouTube offline before in some places, but the big one that they were very proud of, and I think is actually quite astounding, is offline maps. So you can, if you're on Wi-Fi, you can download, say, the map for any city, Jakarta or something like that, although Jakarta is a pretty huge city. You can download that and you can use it in offline mode. So if you lose your connection, like you're going through a tunnel or something like that, but even more so, if you lose your connection for hours, you still have that data. And by data, what I mean is, yes, you can get turn by turn directions. Yes, you can get business listings. You can even get business reviews. So all of those business searches, directions, reviews, all the stuff that you really use with Google Maps is going to be in there in an offline capacity. And, there's a little bit of forethought that has to happen. It's not completely magical, but I thought that was really cool. And that also ties into an update that they gave on Project Loon. CNET is reporting that uh, Project Loon can now provide internet access to a land area the size of Rhode Island with speeds of 10 megabits per second, which is as fast as a landline. It's as fast as broadband or cable internet. So Project Loon, if you don't remember, the balloons that they have been testing, and of course, as Google does, they keep making these balloons better and better and better. They want to connect everyone on the planet. And Project Loon is a methodology of doing that. It actually started as 3G. They were trying to use 3G, but now, as the infrastructure gets better, they're looking to implement 4G LTE and provide Wi-Fi service to people on the ground. So that's really huge for, again, those emerging markets. Although it was interesting that they didn't give any status update on Project Fi, which is their wireless carrier. So we didn't get anything of that, but definitely a lot of very friendly things for those emerging markets where Google has a really good presence because Apple is a premium product. And they did do a little bit of talking about these lower power devices, some of the devices that maybe can't push the envelope like some of these other things. And speaking of those lower power devices, testing for those of you who are developers, this is a big thing. And as a matter of fact, a friend of mine who used to write for me at the Unofficial Apple weblog worked on this project, and I think it's pretty cool. So one of the things that you have a problem with when you're an Android developer is fragmentation. Let's face it; they didn't want to admit it for a long time, but I think if you look at the diaspora of Android devices out there, it's pretty vast. And so it becomes difficult for a developer to say, well, I've tested on the top 20 or 30 handsets. For any sort of independent developer, that's completely onerous. And it's ridiculous to consider that they would have 20 or 30 different smartphones at their disposal to be able to test on. And Google knows this, but Google also wants to provide a great customer service. So what do they want to do? Well, the idea is, how do you test these things without having those physical devices in front of you? And so what they figured out was a way to cloud test. You're actually able to upload your code and run it, and Google does a check through, I think they said, the top 10 smartphones, and it's a smartphones in different categories. So you're talking about the best of the cheapy phones, you're talking about the best of the high end, you're talking about the mid range. They really want to try to get this spread, and they give you crash reports, they give you speed reports, they will send you, you upload it, they test it, you get a file back that has all the diagnostics and testing that you needed. And so for developers, that's a free service, and it's something that Google is really pushing hard to make sure that the experience is the best and as consistent as possible, because that is something where Apple had a real advantage, is in providing people not just a less fragmented area, which is, again, it's almost impossible to do that as time goes on. If you're still writing apps for the first generation iPhone, I feel bad for you. Um, it's just extremely, extremely difficult to do that. So those of you who are deploying Android apps, you're going to be really, really happy about that. One other thing that I thought was interesting that is perhaps not as relevant, but I thought it was really cool. Cardboard version 2, they talked about how many people are getting into VR, and they introduced a couple of things like Expedition, which is for the educational market. So kids can strap on the goggles and they can go and actually travel undersea or to another country or even another time and experience that. And then Jump, which is, they're building a camera rig, so you'll actually be able to film 3D VR video and deploy that. Now, the curious thing about this is this kind of goes back to the very early days of computing. Bill Gates, as a kid, actually rented cycles on a supercomputer to learn how to program. And that was his high school had a program where they did this. And Google is kind of going to be doing the same thing, because the 3D video at full HD resolution, you're talking about a lot of video. They showed a rig that had cameras positioned all the way around it. So you're talking about a ton of video that has to be stitched together, synchronized, and then melded and then spit out as this VR file. Well, I hate to tell you guys, but even your Mac Pro on your desk doesn't have the power to do that in a timely manner. We're talking about like a lot of number crunching. You could let it sit for a couple of weeks and maybe you'd come back and you'd have a couple of seconds rendered. So this is a big problem. How do you allow people to render this stuff when they don't necessarily have a Bitcoin farm at home? Well, again, Google, very intent on creating cloud solutions, they have a cloud solution. And so you're going to be able to upload the video that you take with this. Google will then put it on their servers. They'll do all the processing, and then you'll get a rendered file. Now, this won't be open to the public just yet. They really gave no date for that. They're going to have specific content creators that they're working with to start using this. They've already started using this a little bit, but they're going to be rolling it out. And so I would anticipate that production houses and whatnot will begin using this over time. So we're going to see a really, really nice uptick in VR content, which was something that was sorely lacking, basically, over time. And people got a real kick out of that. Uh, so, like I was saying, with the emerging markets, Google is pushing very hard on the idea that the network is critical, but when the network fails you, they have a fallback mechanism. And I think with Google Photos, also one thing that was a concern and they promised that they wouldn't be doing this, which is that they said that they wouldn't be using your data in the photographs for their own purposes. Now we have yet to see how that manifests itself necessarily. Of course, you can do face tracking, you can do face recognition and whatnot, so you can easily group your photos. So we have yet to see really how some of these things work out, and we have to keep in mind that Google's primary model, of course, is data, and really what they're trying to do is bolster search, and they're trying to bolster discovery. So a lot of these things open up some questions about privacy and about some other things. So when we're talking about these network ideals, it's good to keep in mind where Google's coming from in terms of their monetization and their model. Uh, One of the things that I thought was interesting was that they didn't give much of an update on the self-driving cars, and that's another thing that's sort of an out there project. Of course, they have Google X, their incubator kind of. Well, it's not really an incubator; it's like all the crazy projects and whatnot. And so they've been working on self-driving cars for a while, and they said that progress was being made, but it's really going to hinge on, again, the networking capabilities. If you have a solid network connection, then that's going to make that car that much more effective. But you can also see that where testing the driverless cars has come in, they've realized, well, okay, if we don't have a good network connection, then we can compensate maybe by having these like offline repositories. um, well, that is most of the Google information, and so now we're going to go into a little bit of the. We're going to go into Arduino for a moment here, and excuse me while I move some things around. I'm going to go into the IDE for Arduino. It's a simple little application. It's a Java application, and let me come in here and hold on just a moment whilst I switch over. There we go. Okay. So what we're looking at here is Arduino code. And oops, let me get my notes up here. Okay. In this program, it's going to be a little bit hard to see because of the code. I'm going to try to sort of zoom in on some of the stuff if I can. I'm not sure how well that's going to work, but what I want to highlight here is up here at the top. What you have with Arduino is very much it's the same thing that you see with any programming language, where you have to declare some things, right? So this has two main functions, and most Arduino programs actually have these functions, because what you have is a setup and you have a loop. And the reason why you have a loop is that, if you remember, we talked about Arduino is not like Raspberry Pi in that uh, it's not a self-contained computer. It's really just a control chip. So we actually have to keep it with a heartbeat, and this loop sort of does that. We're also going to initialize a variable here, which is the switch state, and we're going to keep an eye on that, and we have to declare that obviously as well. And then on this next area, we've got a setup for the pin modes. So you can see that these functions are pin modes. They take arguments, which is which pin they're actually looking at, and the output or input. And what that means is you can actually set each pin dynamically to say this is now an output pin or this is an input pin. So it can be looking for something or it can be sending out something. And then we have down here, we have our loop, where we set up something where switch state is actually going to be reading the input on pin mode 2, which is what this is right here. We set pin mode 2 to input. So that's where the loop is going in, and it's using the digital read function with the argument of 2 to pull in that second pin and see what it's saying. And then guess what? We have one of our favorite things in the whole wide world, an if-else statement. So in this case, we have if the switch state is low, in other words, the button is not being pressed, then we write it so that the green LED is on and the red LEDs are off. And again, you go back to the pin modes back here, that's the output. So we're giving these things the output of high or low, and it's essentially an on-off state. Else, if the button is being pressed, then we take the green LED and we turn it off, and then we actually switch between the red LEDs. We actually toggle the red LEDs on and off. And that's down here where we have a delay, which is again your standard sort of thing. And this we have a 250 tick delay, which is it's 1,000 ticks for 1 second. So that's like a quarter of a second. And then down here we write high and low, which is reverse. So 4 and 5 were low and high. Now it's 4 is high, 5 is low, and then we delay again. And that's to give a sort of blinking effect. And then finally, we just go back to the beginning of our loop. Now I'm going to come back to me. There we go. And I'm actually going to show you what this looks like. So we've looked at the code, and now we're going to actually look at what the Arduino itself does. And here you can see that I've got my Arduino, and over here, this is a typical breadboard, right? So you've got these on the sides are running this way so you can run power to things. And then here, these are running from where you are, it's running horizontal. So we've got vertical and then we've got horizontals in here. So these are our red LEDs. Here's our green LED, and then here's our power switch. And of course, we have a couple of resistors, which you do for electronics sake. Here's the actual Arduino chip. And it may be hard to see, but we actually have a couple of things popped in here. And that's actually the voltage, that's the power that we're getting right there. And then over here, this is like our in-out bus right here. And so what you see is we have a couple of wires, 3 wires plugged in that are going to these LEDs to tell them whether to turn on or turn off. And the thing about Arduino is that it doesn't have its own power source. So what we have is a little USB plug right here. And I've got this plugged into a computer, and that's really all it's doing right now is going to be feeding in power. But when we program this, we actually take that file that I was showing you and we upload it into the memory of the Arduino, and it can only store one program at a time. Which again, that differentiates it from the Raspberry Pi, which has an entire operating system, so it can run multiple programs. Whereas the Arduino really just has one memory space for a program at a time. That's why it's a microcontroller versus a full-born computer, right? Okay, so I'm going to plug this in. It's a little bit hard to plug in. There we go. And what you end up seeing here is the light comes on up here to let you know that you've got power. And I'm going to get the lighting here so that you can see. So the green LED is actually on right now. And what I'm going to do is I'm going to push down on the button. And as I hold down the button, you can see those 2 red LEDs blinking back and forth. If you're going to time it, that is actually a quarter of a second between each one of those blinks. And I let go, and it turns the green one back on. So that is a really, really basic Arduino application. But as you can see, it's essentially like writing any other application where you have to declare variables, you have to pull in other functions from outside, an outside library, declare that, set those things up. It supports if-else loops. It supports, delay, timings, all of those sorts of things that you would normally find in any controller chip. And this, but the thing about Arduino is that you saw from this, the code is extremely simple. It's extremely straightforward, and it's a great learning tool. Not only that, as we discussed before, if you're needing to do prototyping and if you need to deploy something as a temporary situation, Arduino is actually very effective for that. You're talking about a unit cost of like $40 or $50, and that's for a kit with a lot of pieces and parts. You can get the Arduino chips themselves for much cheaper than that. And if you buy a whole bunch of them at once, they get even cheaper. So Arduino, very simple, low cost electronic solution that has a robust programming language that's available to it. And I encourage anybody to just check it out from a hobbyist perspective, but I think it's also well worth the effort for people who are out there building things to look at this as an opportunity to build stuff on a hardware side with their software and deploy it. Because a lot of people are starting to look at that as we get into the Internet of Things, and we're looking at, point of sale and all these other great things that are starting to open up. Arduino is an excellent, excellent solution for that. So I'm going to wrap up here, and I want to remind everybody that next week I will be, or I'm sorry, not next week, the week after that, I will be at WWDC in San Francisco, and we'll be looking at all the stuff that Apple's talking about. Next week, I'm actually going to be talking to a friend of mine who runs Fibo. Fibo is a video app, and he's basically a one-man operation. He's built this video app that's really beautiful. It runs on Apple TV, it runs on iOS. They've got a new version that's coming out soon. And we're going to talk to him about what does it take to build a video application when you don't have the money for servers, you don't have the money for the marketing push and all these other things. How did he do it as one guy, build this beautiful app that ties into all this video content? And what are the concerns that he had in terms of bandwidth and other issues? So stay tuned for that next week. This is Victor Agreda Jr. for Coders at RCR Wireless. Thanks for watching.
Coders is a production of RCR TV News. To reach Victor Agreda Jr. or to suggest a show topic for Coders, you can reach him on Twitter at Superpixels. For all the latest news on wireless code and the whole world of wireless, check out rcrwireless.com.